Hello, my name is Vishal, and today our session will be of number systems, the very first chapter of class ninth. Okay, number systems, numbers 1, 2, 3, 4, -1, -2, -3, 1000, 1 lakh, any number, of course. What are number systems? Number systems consist of various numbers. Of course, since childhood we have studied about the various numbers: natural numbers, whole numbers, integers, and then there are this. Of course, three of them are the most common. There are these fractions, and then what to say? Rational numbers. You have studied rational numbers in class seventh. So what is this? In this chapter, we'll be studying the basic concept about everything, every numbers that we have been studying since class one. Okay, so I'll give a brief review about this chapter right now, about the topics that we'll be discussing for today. The first one is natural numbers and the whole numbers w. I'm writing the abbreviations, acronyms, because we'll be studying it in detail just now. I just a brief preview what I'll be teaching. And then the integers is written by Z, and then there is this rational numbers, then there is irrational numbers, of course, then there is this real number. Okay, then I hope so we'll be doing exercise number 1.1, and then we have this irrational number topic. Irrational number, I hope so that will be the first thing that will be this will be the first class when you'll be dealing with irrational numbers. And then I hope so we'll be doing exercise number 1.2 in today's session. And then I'll give you some concepts on irrational numbers, solutions, and exercise 1.3 will be a homework to you, of course. Exercise homework to you, because I'll be teaching you some of the questions, and then of course exercise 1.3 will be solving in the next session. So till here, that will be our session for today. Okay, so let's start without wasting time. Now, maintain a copy for maths. Maintain a copy for maths, because unless and until you are having a copy and a pen and you are watching a video, it's not like a movie going on. You just have to take a copy, you have to pen, and you have to jot down everything that is being taught, because every time you won't open your laptop and won't open your videos and go to your mail and all. That's time taking. You got your notes. When you do it yourself, you learn. Of course, you see, you learn. When you do it yourself, it remains in the mind. Okay, so let's start with the natural numbers. What are natural numbers? Now, natural numbers, they start from 1, go on up till infinity. Infinity, the value, we don't know. Whole numbers, denoted by W. Natural number denoted by N. Whole numbers start from 0, 1, 2, 3, 4, so on, 100, 1000, lakh, and so on up till infinity again. Okay, these are whole numbers, natural number, whole numbers. And then coming to integers. Integers include all whole numbers, but from the negative infinity to positive infinity. Dot dot dot, -3, -2, -1, 0, 1, 2, 3, 4, and so on. Yes, of course, we have negative numbers also, right? Integers. After integers, we have this rational numbers. Rational numbers are, the numbers which can be expressed, the numbers that can be expressed in P upon Q form, where Q is not equal to 0. Q form where Q must not be equal to 0, because any number divided by 0, the value is not defined. Okay, you must remember this thing. 1 upon 0, sorry, 0 upon any number, let's say 100, it is equal to 0. It is equal to 0, but not this. 1 upon 0 or 1 lakh upon 0, it will be not defined. Okay, got it. So this is your rational numbers. These are your rational numbers. Now you'll say, sir, what's the difference between rational number and fractions? You got it there. I'll give you the answer, the difference between rational number and fractions. That's the first question that arises in every kid's mind, and I know you all, of course. So rational number 4 upon 5, can it be reduced to any form? Nope. You know, now we do it as 8 upon 10, and then 16 upon 20, and then 160 upon 200, right? Or 81 upon 162. Okay, rational has a ratio in between, right? And ratio is always the smallest terms, the lowest term. So when you reduce it, 81, 1 is to 2, that is your rational term. It cannot be further reduced. This is your rational number. It cannot be further reduced. These are fractions. A rational number is a fraction, but not all fractions are rational numbers. Of course, rational number include everything. It includes everything, right? When fractions, when you reduce it to the simplest term, it becomes a ratio. It is a rational number. A fraction is a rational number. Rational number includes everything, any number of p by q form. There is no difference between fraction and a rational number. The only thing is fractions come under rational numbers. It's not different, right? When you reduce it, it becomes a ratio, and we, for our convenience, we take the fraction, the simplest term to be as a rational number, though these all are rational numbers. Okay, so that is how fractions and rational numbers are related. And then there is irrational numbers. What's it? Irrational numbers, the numbers that are not rational, simply. The numbers that cannot be expressed, the numbers that cannot be expressed in P upon Q form. Okay, let's say I'm just giving you one assignment, and I won't be checking it, of course. Assignment, divide the value 22 upon 7 or 1 upon 3. What do you get? You get a very long value, very long. It goes and on, it goes on and on and on, and it doesn't end, right? So that kind of numbers which cannot be, if I take this number, or I give an example, let's say root 2 value is 1.414. We just take the 3 decimal places, but further we do not take. When root 2, can you express root 2 in the form of a rational number? I hope not. We cannot, right? Root through, or 0.10 100 10001 0000 1000001, and so on, and dot 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 dot. These kinds of numbers are irrational numbers which cannot be expressed in the form of p by q. Okay, so this is an irrational number, and then we'll move on to some exercise number 1.1. This whole chapter is actually very easy. Now, before going to some of the moving on to the exercises, I'll ask you some questions, and you're gonna say whether it is a true or false. Every whole number is a natural number. This is an example number 1, page 3. Question 1. Every whole number. The question is, every whole number is a natural number. Is it true or false? Come on. It's false. Why so? Because whole number starts from 0, but natural number starts from 1, right? So we can say every natural number is a whole number, but not every whole number is a natural number, okay? So the right sentence is every natural number is a whole number, because you know natural number starts from 1 and goes till infinity, right? This comes under whole number which starts from 0 and goes till infinity, okay? That is the reason why every natural number is a whole number, but not every whole number is a natural number. That's a false statement, okay? Then there is example number 1 part second. The question states every integer is a rational number. Every integer, may it be -1, may it be -2, may it be -3, may it be -1000, may it be 0, may it be 1, or may it be 1, 2, 3, 4, 5, 7. Any number. Is it a rational number? Can we express it in the form of a rational number? Can we? Yes, of course it is a rational number, because any whole number divided by 1 will be the same number, right? Yes or no? Of course it will be the same number. Hence, yes, they are. They are, because they can be expressed in P by Q form, expressed in P upon Q form when divided by 1, right? Easy. So this is it, part 2. And coming to part number 3. Part 3. Part 3 says every rational number is an integer. Can you imagine every rational number? Let's say we have 1 upon 3. Is it a rational number? Yes, it's a rational number. But is it an integer? No, it is not an integer, because integers are whole numbers. What are integers? Integers are whole numbers. It does not include fractions. Okay, so every rational number is not an integer. Got it? Okay. Now, after these examples, we'll move on to exercise number 1.1, and that's a very easy exercise. If you have understood these simple things, then exercise number 1.1 is very easy for you. I'll just, you just listen to me and try solving it yourself. Okay. Exercise 1.1. Is 0 a natural number? You got the answer right? No, 0 is not a natural number. Why so? Because 0 comes under whole number. Right? Can you write it in the form of P by Q? Cut. Resume. Okay, so exercise 1.1. The first question is 0 a rational number? Yes, of course, 0 is a rational number. Just now I showed you every integer is a rational number, because that can be expressed in the form of 0 upon 1. 0 can be expressed in the form of 0 upon 1. Hence, it is a rational number, right? So this is a rational number. Of course, can you write in the form of P by Q? Yes, of course, we can write in the form of P by Q. The second part is find 6 rational numbers between 3 and 4. This question I am going to do it on board, and you must write it down. Of course, I know you are writing it down. Question number 2. Rational numbers between 3 and 4. Can you imagine how many rational numbers can come between 3 and 4? Okay. 2 methods. I'll tell you both the methods, and whatever is easy to you, of course, you can do that. In class 7, I have there were 2 methods. I'll 3 upon 1, 4 upon 1. This is one. We have to put in 5 rational numbers. What we do is that we multiply the denominator by 10 and the numerator by 10. The question remains the same. 30 upon 10 is 3. The same in here, into 10 into 10, the 40 upon 10. Now, can we write rational numbers in between? 31 upon 10, 32 upon 10, 33 upon 10, 34 upon 10, 35 upon 10. That is again the 5 rational numbers, and it's your choice if you want to go with this method or the alternate method is you got 3, you got 4. What you do is that mean of them. 3 plus 4 whole upon 2, it is equal to 7 upon 2. Okay. Now what you do is that 3 and 7 upon 2. 3 plus 7 upon 2. That just comes out to be whole 2, 1 and 2 LCM 2, 1 to 6 plus 7. That is equal to 13 upon 2. Okay. Okay. 13 upon 2. 7 upon 2 and then this. The first one, first step here. You get the first rational number. Then the second step. 7 upon 2 plus 4. 7 plus 8 upon 2. Same. 4 upon 1, 2 is the LCM. Right? 7, 8, 15 upon 2. And then you go on 15 upon 2 and 4, the third step. And 15 up 3 and 13 upon 2, the third step in here. And you get 5 rational numbers. The here 1, 2, 3, 4 and 5 rational numbers. This is another method and it's a bit complex. The easiest one is this. It's your choice, whatever to follow. If you want to follow this, it's no matter. Coming to question number 3, it's again to find out rational numbers in between two given rational numbers, of course. So we have question number 3, 5 rational number between 3 and 5. We got 3 upon 5 and we got 4 upon 5. What we do is that how many rational numbers we have to find? We have to find 5 rational numbers. What we do is that we multiply it by any number. Let's say we multiply it by 2 into 2. What do we get? 3 to the 6 upon 10 and here is into 2 upon 2. What do we have for 2 times 8 upon 10? Now the problem is there is just one rational number in between. Okay. So what we'll have to do is that we'll multiply it with a bigger number so that we can get as many rational numbers as we can. Let's say we will do 3 by 5 into 10 into 10. It comes out to be 30 upon 50 and 4 upon 5 into 10 into 10. What is it? 40 upon 50. And there are 10 rational numbers all in all in between. So we can write any rational number: 31 upon 50, 32 upon 50, 33 upon 50, 34 upon 50 and 35 upon 50. These are the rational numbers in between the two rational numbers 3 upon 5 and 4 upon 5. Okay. Easy. Got it? Moving to question number 4. Listen nicely. Okay. I'm not going to show this on board because it has nothing related to the board. The question is, every natural number is a whole number. Is it so? Of course, yes. In the example we did, every whole number is a natural number. No, sir. Every whole number is not a natural number. But yes, every natural number is a whole number because natural number starts from 1 and goes till infinity, whereas whole number starts from 0 and goes till infinity. Hence, natural number comes under the whole number. Okay, natural number belongs to whole number. Yes, every natural number is a whole number. True, sir. Okay. So, moving on to question number 4, question number 2. Every integer is a whole number. False. Every integer cannot be a whole number because whole number starts from 0 and moves on till infinity. So what is it? Every integer is not a whole number, right? The positive side of the integer from 0 till infinity, from positive side from 0 till infinity, that's they are integers and they are whole numbers, but not the negative side. Okay. Coming to the third part, every rational number is a whole number. Every rational number is a whole number. Is it so? Just now, 1 upon 3, I told you, every rational number is not a natural number. Every rational number is not an integer. Every rational number is not a whole number. 1 upon 3, can it be expressed as a whole number? I hope not. 1 upon 3 is a rational number. It cannot be expressed as a whole number. Okay? Easy? I hope you got it. Now, that was exercise number 1.1. And we'll be moving on to exercise number 1.2. But before that, I'll be telling you some smaller things, how to locate the irrational numbers or the square root on a number line and all, right? We know how to make a number line, of course, 1 and so on. But this time we'll be locating the irrational numbers on number line, okay? I told you irrational number concept, okay? Coming to page number 7, example 3. Locate root 2 on a number line, right? What we do is that we draw a straight line. Of course, take your scale, you draw. Mark any point. Let's say this point is the origin. 0. That's the point 0. With the help of a scale, with the help of a ruler scale, you mark 1 centimeter, just 1 centimeter. This is 1 centimeter from it, 1 unit. Okay, 1 unit. Okay, 1 centimeter. Okay, now what you do is that you have to find out the value of root 2. Take your compass, take your protractor. Okay, if the compass will be a complex thing, take your protractor, place it here and mark 90 degree. Of course, you are marking 90 degree. Place your ruler scale and then draw 1 centimeter here. This is again your 1 unit. This is again your 1 unit. Join this 0 to this point. Okay. Now take your compass, place it here, and then take your pencil. This is the radius. Join this. So what will happen with this as radius? It will come and cut it somewhere here. That is your root 2. Okay. How so? Mathematics, Pythagoras Theorem. Okay. Pythagoras Theorem. Now what is it? 1 square plus 1 square will give us, let's say this is x square, or x is equal to under root of 1 plus 1, it is equal to under root of 2. So we got the value of x as under root of 2, and then you will just use the compass and mark it. Did you understand? Okay, I'll tell you one more example. Let's say example number 4, that is about root 3, and then I hope you will better understand it. So it's example number 4, and locate root 3 on the number line. Okay, my handwriting is a bit bad, but bear it. Okay, it's you'll understand it soon. Now, the first step, drawing a straight line, taking a point, marking it 0, right? We have to go for root 3, right? So we'll have to take 2 steps first. Now 0 to 1, we'll draw a line 0 to 1. This is 1 unit, 1 centimeter line, 1 centimeter. With the help of a ruler scale, 1 centimeter we took it. Marking 90 degree, we are making 1 unit here on this side. Right? This is a little bit making it shorter. This is 1 unit on this side. Joining these 2 points, that becomes your root 2 point. But we don't need root 2, we need 3. So coming to this thing, if this is root 2, right, root 2 square plus 1 square whole under root is equal to x. Now, how to make root 3? You'll understand this thing when we do. Now, placing your protractor here, we'll place this protractor here and marking 90 degree. We mark 90 degree, right, 0 to 90, and then we'll make 1 unit here, 1 unit. Okay, 1 centimeter. If you're not understanding it, let me make it again. We'll make 1 centimeter line perpendicular here, right? We're not using the compass or anything. We will be using the protractor, of course. And then we join this. And then we place the compass. Now we place the compass, and it's like somewhere here. That is your root 3. That is how you make the value root 3. Okay. Now, this thing, what was I doing? Root 7. If someone asks you to make root 7 or root 5, what will you do? Root 5 is easy. 2 square plus 1 square under root. So you will take 1 unit and then 2 units, and then you will make 1 unit, 2 units. Or else you can just move on like this. Root 3 and then 1, they will get root 4, and then 4 and 1, you'll get root 5. Okay, so that is how you'll make the various irrational, you'll mark various irrational numbers on a number line. Okay, moving on to exercise number 1.2. The first question, state whether the following statements are true or false. The first one is every irrational number is a real number. Now, I didn't tell you about real numbers. Real numbers like this universe, this multi-big universe with millions of stars. It has got stars, it has got galaxies, it has got constellation, it has got black holes and everything. Same is the case with real numbers. Real numbers is this universe, and every number, may it be natural, may it be whole number, may it be integer, may it be rational, may it be irrational, may it be complex numbers. I'm going to tell you about complex numbers. It is here. I'll have to explain it to you in question number 2. So these all numbers come under real numbers. Okay, so yes, it's true that every irrational number is a real number. Okay, coming to the second point, every point on number line is of the form root m. Is every point on the number line is of the form root m? Is it so? We draw a number line 0, root 2. Yes, of course we can locate it, root 2. Root 4, yes, of course we can locate it 2. Okay, now coming to the negative side, minus root 2. How will we find it out? It's impossible to find this negative square root. Okay, hence this statement is false, because if m is negative, minus 2, minus 3, minus 4, it is impossible to find the square root of it, and that is known as complex numbers, which you will be studying in class 11. Okay, that is under complex numbers. Coming to question number 3, 1/3. Every real number is an irrational number. No, every irrational number is a real number, but every real number is not irrational. Real number can be rational, real number can be natural, real number can be any numbers that you want, but real number is not irrational, not necessarily, right? Question number 2, are the square roots of all positive integers irrational? Are the square root? Okay, so you know what a square root is, you have studied it. So question number 2, let's say we have a square root of 4, it's 2, but square root of 5 or square root of 2, it's 1.414, it's 2 point something, right? So these are decimals, hence are square roots of all positive integers irrational? No, root 4 is 2, but root 2, this is irrational, but this is a rational number, right? Root 9 is equal to 3, rational, this is irrational, this is rational, right? This is a rational number, these are irrational numbers, not necessarily, hence this statement is false. Example, 4, 9, 25, 16, these all are examples of rational square roots. Okay, question number 3, show root 5 under square root of 5 on a number line. I just explained you how to represent root 2, then you will have to explain root 3, and then there will be root 4, and then there will be root 5. You're gonna do it yourself, do it once. Okay, question number 4, it's an activity where you'll be making this again square root chart in a square root diagram in a chart paper, and it will go on increasing its size. You know, it's an activity. If you want to, you should. Of course, it's a classroom activity. Now, coming to real numbers and decimal, this exercise number 1.2 comes to an end, and we'll be moving on to real number and the decimal expansions, and I'll be giving you a little bit of concept, and then our session for today will end. Or else, yes, of course, we shall end it now. No, let's do the concepts, and then I'll be giving you 1.3 as a homework, and try them. Okay, try them. Now, let me give you some of the concepts. Division. 8 upon 5 we are taking, and then we are taking 10 upon 3, and we are taking, what say, 1 upon 7. Okay, now 8, 5, 5 1 times 5, 3, decimal 0, 6, 30. This is called as terminated. This type of decimal is terminating decimal, where it gets terminated somewhere or the other. Let's say we take 5 divided by 8, again the opposite one, decimal 0, 5 6 times is 48, 2, and decimal 0, 2 times is 16, 4, 0, and 5 times is 40. It 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 terminates, right? It terminates somewhere. These are called as terminating decimal. Coming to these two kinds of decimal, 10 upon 3. Now 10 upon 3, 3 times is 9, 3 times is 9, 10 minus 9 is 1, decimal 0, 3 times 9, 0, 3 times 9, 1, and this will move on. These are called as non-terminating, right? Non-terminating. Now non-terminating is of two types again. Of course, non-terminating is of two types. After I'll divide this, we'll tell you this one. 1 divide 7, decimal 0, 1 times 7, 3 decimal 0, 4 times 28, 2 decimal 0, 2 times 14, 6 decimal 0, 8 times 56, 4 decimal 0, 5 times 35, 5 decimal 0, 7 times 49, and again it is here again, right? So what is happening? It's just moving on and on. It's going on, right? So what is happening? These two decimals here, is there any repetition up till here? Maybe it can happen. Maybe there will be no repetition. Now, in case of repetition, we call it as non-terminating. We call it as non-terminating recurring. That is repeating, right? And in case of this kind, this is called as non-terminating non-recurring. Okay, kids. Now, we'll be studying about this and this in the coming exercise. Okay, non-terminating recurring and non-terminating and terminating decimals. So take out your exercise number 1.3 and just try doing some of the questions number 1, questions number 2. Okay, and we'll be moving on with this exercise and some of the other concepts in the next session. Thank you, and practice and read the concept, read the number system. It's a very easy chapter. Try doing the questions that I already did. Try doing both the exercises 1.1 and 1.2. Okay, thank you. The end for today.